Legacy students, Marsh here. So today we're going to be doing a video just a little bit different today because I need to be able to draw with a pencil and I need to be able to erase. So I had to go a different route this time. So what you're going to want to have on you, you're going to want to have your notebook. Graph paper is definitely something awesome today. You're definitely going to want a pencil, and it has to have an eraser on it, because if it doesn't have an eraser, you're not going to be able to do it today. Or, like Marsh, have a really large eraser so you can erase. So, what are we going to be doing today? We're going to be graphing piecewise functions. What you're going to want to be able to do is be able to graph them. Not used to flipping pages. There we go. So, what is a piecewise function? What have we talked about with piecewise functions? Well, a piecewise function is made of pieces of different functions which are a result of their different domains, the x values. Notice, these are not inequalities. Not inequalities. Do not shade. Do not use dashed lines. They're always going to be normal. All they are just pieces of different graphs all stuck together to make a Frankenstein function. So, let's take a look at how to graph one of these guys. So we have been working on just the writing of this, not the graphing. I gave you a graph and then you would write them. Well, in this case, we're actually going to draw the graphs. So what you're going to want to do first is you're going to want to draw them like you would. So we're going to draw the line, graph the line, 1x minus 4. Which in this case to me means I'm going to start at my y-intercept of negative 4. So go on my graph here, put a big giant nice dot there at negative 4. Then I'm going to use my slope of up 1 over 1. So up 1 over 1. I'm going to do that for the entire length of my graph. Then what I'm going to do is I'm going to take my ruler here. I'm going to do some connecting of the dots here. There we go. There's my graph there. Now, looking at my conditions here, I can only have this graph if x is less than 3. Which means, with my ruler here, I'm going to take and put it at 3. Right here. Right there. 3. Now, I need to decide which half of my picture do I get to keep. Do I get to keep this side, or do I get to keep that side? So I need to decide where are the x's less than 3, because that's what they're telling me. X's needs to be less than 3. Well, x's less than 3 would be on this side of my graph, right? Because the numbers less than 3 are like 2, 1, 0, dot, 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 dot. Well, I have to then erase this half. So I'm going to take my eraser and I'm going to actually erase my graph here. There we go. Now I need to decide what kind of dot are we going to have at 3. Is it going to be a closed dot or an open dot? Well, I'm going to look over here and I notice that it is a less than symbol, which to me means open dot. So I'm going to make sure it's nice and big so that way Miss Marsh can see that it's an open dot, because otherwise, Marsh can't see that. So that is one half of my graph. Let's graph the other one. So I'm going to graph the function negative 2x plus 1. So I'm going to start at its y-intercept of 1, go down 2 over 1 with my slope, because it's rise over run. A lot of graphing today. There we go. Connect the dots to the best of my ability. There we go. Not the best of lines, but nevertheless. Now, same thing. I want this line here where x is greater than 3. So, put my line here, right at 3, and I'm going to decide which side do I get to keep. Do I get to keep this side of the graph or this side of the graph? Well, in this case, I want the numbers greater than 3. So I'm not going to keep this side because that is the less than side, right? So I'm going to keep this side. So that means from here on, I have to erase. So I'm going to take my eraser here, do some erasing. There we go. And then I got to decide what kind of graph, what kind of dot am I going to have right here? Because this is where the 3 is, right? Well, it isn't equal to, so I have to have a nice big closed dot right there so Marsh knows it's closed. Notice, guys, open dot, closed dot. That always should happen. That's why today erasers are the coolest thing ever. Let's try another one together. So I have this piecewise function now. Ooh, there looks like there's a v. Tons of fun. So let's graph the absolute value of x minus 3. So very first thing, I know it's a v. And that minus, it's in the inside. So that means we're going to go right? We're going to go to the right. This way to the right. Have a dot right there. And then it's going to go for my arms. I'm going to go up 1 over 1. So it's going to be a v like this. Whoa, Marsh can't draw V's. There we go. Not too bad. Now, I'm going to take my ruler. I'm going to put it where 5. I'm going to look at my boundary area. So 5 is where my boundary is. Right there. Take my pencil out of the way. So now, I want to know which side do I get to keep of my graph. Do I want to keep the left or the right? Yeah, I want to keep the left, right? Because I want the numbers less than 5. And these are where the numbers less than 5 lie. So I got to erase this side of my graph. That piece got to get erased. So at 5, starting with 5, I'm going to erase this side. There we go. Now, I want to have an open dot at 5. So that means right here, I'm going to put a nice big open dot so Marsh can see that. It's not even that good of an open dot. Marsh, come on, Marsh. There we go. There's a nice big open dot so that I can see it. Now, let's graph the other piece of my function. I have 1/2 x minus 2. So I would be starting at -2. I'm going to go up 1 over 2 for my slope. Up 1 over 2. Up 1 over 2. Connect them to the best of my ability. There we go. Now, again, ruler. I want where the numbers are greater than or equal to 5. So I'm put my boundary on 5 here. And I need to decide which side of 5 are we keeping. Are we keeping this side of 5 or that side of 5? Well, in this case, I want the numbers greater than 5. So I'm going to keep this side of 5 right here. This guy right there. Sorry, my hand's getting in the way. They're right there. So I want to erase this side of my graph. So I'm going to take my eraser. Whoa, this one's weird. Do you see how that is? That guy was right in the middle. So I got to erase all over here, until I hit 5. So it's going to be really close. There we go. Notice it's kind of ending up in the middle. And a big closed dot's needed. So I'm going to close dot right in the middle there. Clean my erasers off. There we go. And that would be my graph of my piecewise function for this particular one. Now, can a v be made not a v? Yes. If I would have limited my domain for that piece to 3, it honestly wouldn't look like a v. Another way you can do this as well is you can actually consider this to be 2 pieces. Be careful with that. Make sure your V, sometimes I might not ask you to graph the entire V just because of that's just the way it goes. Let's try one more. We get to do what's known as a step function. Basically, it's going to look like stairs when we're done. We did a couple of examples of evaluating like this and also the writing ones, but let's take a peek at this. So I have 3 here, and I have 0 to 2. So, well, the graph of 3, that would be a line going like this. Make sure it's nice and dark so you guys can see it. Right there, right? Well, I want to keep 3 between 0 and 2. So 0, x is 0 right here. Between 0 and 2, I want this line. So I need to erase all right here, and over here, and over here. All of this gets to get erased today. There we go. Okay, now I want a big open dot on 0, and then a big closed dot over here, because that's what it tells me here. Open dot, closed dot. Now, between 2 and 4, I want a 1. So that would be the line going right here, right? Right at 1. So I want an open dot at 2, closed dot at 4, and then a line connecting the 2. Last one here. So I got a 5, and that's between 4 and 6. So on 5, right here, this line right here that I'm kind of imaginarily drawing here, I got 4 right here, and then 6 right there, close down on 6, draw my lines. See how they kind of look like a steps? A lot of times you'll see step functions kind of look like this. Basically, step functions mean that they just are not, they're just a normal number, not with an x or anything like that. Not a linear in that regard. Just a constant function, actually, would be the name for it. And that's the end of this video. See you later, Savers.